This here is a set of data that was gathered right before and right after a certain period of time after an intervention is applied. We have here 3 columns. The first column is for matched student identification. These numbers here just to identify which student is that. We have here 140 students. The second column is actually the level of anxiety of these students before a certain intervention is implemented on a math classroom. Okay, we have here very high anxiety, moderate anxiety. We have the low anxiety and very low anxiety. This is also the same measurement on the third column, but this is a measurement of their anxiety on the math class collected or recorded after the said intervention. Now for this, we could see that there is a period of time and then there are 2 sets of data, but each of the students has responses in both. If we talk about numerical data in nature, just like say for example, if we have scores before and after, we can use there the paired samples t-test, a parametric test to difference with whether there's a difference between the scores of the students before and after a period of time. But since here our data are ordinal in nature, we call them ordinal because we can just simply arrange them into order. These are non-numerical in nature. Therefore, we can use here the non-parametric equivalent of the paired samples t-test, which is the Wilcoxon Signed-Rank Test. But before we could use the Wilcoxon Signed-Rank Test, there are 3 different assumptions that should be met. For this video, we are going to test one of the assumptions. We will not be checking yet the Wilcoxon Signed-Rank Test here, or the test of difference between the 2 sets of data before and after, or the level of anxiety before and after a certain intervention. We are going to check here one of its assumptions. We have 3 assumptions before we can use the Wilcoxon Signed-Rank Test. Similar to some assumptions as well before we could use the paired samples t-test for parametric equivalent. Before we go to that, let's examine here the variable view. For our variable view, we could see that the first row here is our first column, just nominal in nature because the numbers there represents the student identification only. Now for the second column, we have here anxiety of the students before, we have here this label, and we have here these values. So even if these are not numerical in nature, we can assign numbers because we can assign order into them. 1 being very low anxiety, 2 low anxiety, until 5 which is very high anxiety, or you could also rearrange it depending on what you want. Of course, you could add labels here just like this. You can simply add 1 and you can apply here very low anxiety. But of course, since it's already there, we were not going to click this one here because it's already there. Okay, again, it's an ordinal in nature because we could arrange all those numbers. Same thing will go to the anxiety after. This is our third column earlier in the data view. Level of anxiety after a certain intervention, and with the same values 1 until 5. So going back here, again, before we could use the Wilcoxon Signed-Rank Test, there are 3 different assumptions. The first assumption is that our dependent variable, we have these results here, are actually in ordinal, at least ordinal in nature. Okay, at least ordinal. So level of anxiety can be in terms of ordinal. So we already checked that first assumption. The second assumption is that we have here pairs of our matched pairs. Our independent variables has matched pairs. This is our independent variable. It's based on time before and after a certain intervention. And each student here, 1 to 140, has a response before and after. It should be given like that because if one student has no response before or after, we remove that student so that we will not be able to make incorrect generalizations later. But here comes the third assumption. This is what we're going to test in this video. The distribution, this distribution should be symmetrical in shape. That's the third assumption before we could use the Wilcoxon Signed-Rank Test. Now, for its parametric equivalent, we have the paired samples t-test. For paired samples t-test, we have also assumptions. And one of the most important assumption of the paired samples t-test is the test for normality of distribution. We are checking whether our distribution is not significantly different from a normal distribution. But here, since we're already sure that we cannot use here the paired samples t-test because our data is ordinal, in paired samples t-test, it should be either interval or ratio. So we'll be talking about Wilcoxon Signed-Rank Test. What we're going to examine only is the symmetry of our distribution. This is the test for our distribution. So to check for symmetry, we are going to use here the differences of their ranks. Okay? How do we do that? Of course, as mentioned, these are ordinal in nature, but we have already assigned values into them. You could see those values by clicking this here. And you would see 4 numbers here, but then again, we cannot be using here paired samples t-test because these are just ordinal in nature. What we need to do here is to add another column. So we can add another column here by clicking this transform, and let's compute a variable. Okay, you will have this dialog here. Again, transform, compute variable, and this dialog will come in. Now let's call here differences of what? We are going to check here or come up here with an expression. That's level of anxiety before. You click that here, minus the level of anxiety after. Now, if you're going to interchange that these two, it doesn't matter, because if we talk about symmetry, we're just checking whether according to the median, not the mean value, because these are again ordinal nature, whether the median on that set of shape will have approximately symmetric on both sides. Okay, so you can just simply rearrange if you would like to, but once you're sure with this, you can click OK here. Okay, so this is the result column. It will appear, or the difference will appear on this column here. These are the differences between your assigned values, which are actually again in this assignments, but since we're using the values to solve for difference, we'll have this. What we need to do here now is to use this difference and to check whether there is symmetry in the shape of our distribution. Before we go to that, let's name this one here. Well, let's have differences between the anxiety of students before and after an intervention. Now, this labeling is important because this will what will come out in our graph or table later. So now that we have these differences, this is now the step on checking symmetry. Because if we cannot establish symmetry here, then we cannot use the Wilcoxon Signed-Rank Test in determining whether there is significant difference between the medians or the ranks of these two sets of data. This is how we do it. Go to Graphs, click hover to Legacy Dialogs or click Legacy Dialogs, and you will have here your box plot. Again, this is the process. Graphs, Legacy Dialogs, and box plot. Once you click box plot, you will have this. Let's have just simple and summaries of separate variables. Okay, let's just have this one here. Okay, so once you will have this simple and summaries of separate variables, and click define. Once you click define, okay, you will have this another dialog. What we need to do here is to simply click the differences, the label that we had earlier in the boxes represent. No need to complete all of this here, just simply that. Now, if you would like to go to options just to check whether there are things you want to change, but this is just the same, okay? So once you will have that, you click OK. And once you click OK, you will be given with a box plot. And this is our box plot here. Okay? Now, this is the case process summary. This is a summary of the data that you have entered. Take note, we have 140 students earlier. We have student number 1 to 140, and all of them are counted. Now, let's proceed to this box plot here. This is the difference between the anxiety of students before and after an intervention. Now, this middle here is actually our median of the responses of the student. This is our this shape. Okay, this is our shape here. As you can see from, if you could of course rotate this 90 degrees, but looking at this one here, from median here to the bottom and median to the top, we can see here approximately symmetric on this median here. Okay, with looking like this, of course you would know that it's not approximate symmetry or symmetric if the median is somewhere here or here, right? But this here, according to our test, this set of data or the distribution of our data is approximately symmetric. So going back to our data earlier, With all these differences, using the assigned values for the anxiety of the students before and after a certain intervention on a math class, we have established that our distribution here is symmetrical in shape. With that in mind, if you would like to check whether there's differences between these two data gathering sets of data gathered on different periods of time, we are now safe to use the Wilcoxon Signed-Rank Test because assumption number 3, the assumption for symmetry, has already been established. Let us have that on a separate video talking only about the Wilcoxon Signed-Rank Test. For this video is only for the test of symmetry. See you in the next video.